work that was shown on the test made it evident that you were possibly physically present in class but not mentally. Yeah.
Okay, just like quick like naming thing. Does day 30 mean like it's day 30 school day or day 30 like
In theory it's day 30 since the start of this quarter.
oh quarter, not semester. Thank God. Okay.
Quarter
Wait, month. Really long.
Yeah.
How many days are in a quarter, roughly? Other than too many?
Yeah, you know.
180 divided
Okay, so 5 times 9 is 45.
No, bro.
That's it.
Wow, you are explaining the math to the calculus teacher.
I was not talking to a calculus teacher.
Okay, so the chapter 6 tests, those of you who took it, those are graded and those of you who requested retake scores, those have been put in as well. I will hand them back tomorrow when I believe the last of those of you who haven't taken the test will take it. Okay. Okay.
Oh, right.
Words to live by, there you go. I don't know.
It's for dancers, but I think it applies to life as well.
Fair enough.
So we're done.
Sure. I mean, yeah.
Like studies people that have genuine impacts, not like moments for 2 seconds.
No, I got you. Yeah, it's a whole TikTok thing now, but you know, in the math world, there aren't really like, wow, TikTok math.
Well, there's not really like math trends.
Other math
Throwing down
trends.
some
There's, maybe math degrees, maybe not math trends. Like
Math, no. I do something today.
It's just a general quote. It's not like
fractions are anything. Fractions are in decimal row.
You know,
Actually, it's 2023. I don't want
Don't
to.
erase it.
I know right now we use gradients, but I think in the future it's good.
It's 2023. You're not allowed to have a third decimal place.
Make your own.
Porridge.
Porridge. That's real as
You
fuck.
shall.
She was lazy.
What?
That lazy little girl. That's why her ass got 8. Wait, how does the story end?
I thought that was like one.
Yeah, Laura not even got eaten by
good times. You are being recorded.
2007?
Delete it.
That's like wow.
Yeah, so
No, that's
Conrad and
Conrad.
Nathan, they were chatting. Nathan was complaining like, "Oh my God, the teacher had the nerve to take off points because I got it wrong." Like, have a nerve.
How dare?
Conrad did. Make your own.
But in the new this movie, they're all like together.
Okay, we have stuff to do.
What?
Do we really know?
Have you enjoyed? You guys get a notebook out. Yeah, notebook.
That is something I can do.
That would be lovely. Okay. This is supposedly review. The number of people in basic calc who say it's not review would be most.
So
So
why don't we clarify that 9 times 5 is 45?
Yeah, we've never done this.
It's
And then you have one of these. Cool. We don't have no pages in there no more. Great. Okay, so of course. All right. There is a homework on Delta Math tonight, and it's on all kinds of good stuff. So we're going to go back to linear motion. Like, where are you at the end of all your travels versus how far did you travel? Why? Because y'all don't remember, and it's in chapter 7 again.
What's the derivative of position?
What's the derivative of position?
Velocity.
Acceleration, and then there's jerk, and then it was snap, crackle, pop.
Yes, there is. But, Mayo, if you think about it, change in position. Like you went 20 feet over 5 seconds. Change in position over change in time. 5 feet over 20 seconds, that's like feet per
Acceleration.
second, like, and then acceleration, how is your speed changing, or I should
Oh,
say
wait,
velocity.
no.
Velocity, what's the
Velocity.
difference between velocity and
Yeah,
speed?
let's do that.
Direction.
Direction. Velocity
Like
is a
scale.
vector.
Scale.
And that's why it requires more.
Okay, wait. So, velocity, what's the velocity as the pen's going up?
Positive.
Positive or negative?
Positive.
And what's the velocity when it's coming down?
Negative.
Negative. What's the velocity right when it, like,
0.
0.
right when it stops going up and starts coming down? Right there is when it's 0. And can the pen change direction without hitting 0?
No.
No.
No. Does it have to change direction when it hits 0?
No.
No. So like when I come rocking up to a stop sign, very rarely do I hit the stop sign, slam it into reverse and go backwards, right? So I go up and I stop. And count to 3, because Mr. Officer will give you a ticket if you don't count to 3, and then you move forward again. You did not have to change
When
direction.
velocity hits 0,
Yeah,
acceleration.
I mean, I know you're supposed to.
I do know my brother.
Whenever you get a ticket or anyone near you gets a ticket for not stopping enough, yes, you're gonna count to 3 for a year or 2, because they're expensive tickets.
Oh,
When velocity
Do
hits
you get
0,
points?
acceleration hits 0 as well.
Sorry.
When velocity hits 0, acceleration. No, wait, when acceleration hits 0. No, when velocity hits 0, acceleration hits 0 as well, right?
Nope.
Okay, so why not?
Okay, just because velocity is 0 doesn't mean acceleration is 0. What is the acceleration on the pen that I'm throwing up in the air or dropping on the floor?
Oh, it decreased.
Plus.
There's no acceleration from the force that I put on it. I'm giving it only velocity. What is the only thing dragging it to the ground? Gravity, which is acceleration. Gravity is a constant, forever negative. 32 feet per second squared, or negative 9.8 meters per second squared. Just sassy lassie. So
32 is
the acceleration was forever negative.
Acceleration is velocity, the change of velocity over time.
Mhm. And the
reverse.
velocity at first, when I first threw it, was fast.
And that's why the integral of velocity is acceleration. No, the integral of acceleration is velocity.
Yes.
It's over time.
Yes.
Clarifying.
Cool. I'm gonna put the pen down because I started dropping it. Alrighty. So here we go. So let's look at this problem one piece at a time. Can we still do this? Here is your velocity equation. Jacob, how would I determine when the particle moving at this velocity along the x-axis, so it's just moving sideways, it's not any up and down, when is it moving right, when is it moving left, and when is it stopped?
Would you find where the velocity is 0?
That's a great idea. Eric, when is velocity 0?
That could be 5.
Okay, velocity 0 at 5. So Isaiah, what does that mean?
At 5, it's like not moving.
So at 5, the particle stopped. Why? Because the velocity was 0.
When it's moving, so when it's like positive, it's moving to the left or to the right.
Logan, what do you think? When it's positive, when, no it's, no pronouns. When velocity is positive, is the particle moving right or left?
Right.
Right, because this is horizontal motion. Positive direction is to the right, like positive numbers on the x-axis are on the right, negative numbers are on the left. So how am I going to tell what the velocity is doing at Jackson? What's the velocities? I don't need a number, but I want positive or negative. At 2 seconds, is it positive or negative?
Positive.
Positive. How do you know?
Because 10 minus 4 is positive 6.
So plugging into the equation for velocity, again, I don't care how big that number is, I just want to know if it's positive or negative. Iris, at 7, is velocity positive or negative? Negative. So Francesca, looking at this, which, guys, this is not enough for justification on free response questions, not enough to draw the number line. You now need to say words. So Francesca, when is the particle moving right?
0 to 5
Why?
because it's positive
What is it?
velocity.
And you can use symbols because V of t, that's what that's supposed to say, sorry for the scratch, is greater than 0. So Keith, when is it moving left? Okay. No it. What is it? Moving left when V of t is less than 0, which is, what's the interval again?
5 to 9.
5 to 9? And why did we stop it at 0, start at 0 and stop at 9? Because, and sometimes they make a big deal about the restrictions they put on the word problem, and sometimes they're like, oh, no, 9, infinity, it's all good. I think there's a pretty big difference between 9 and infinity, and infinity minus 9 is still infinity.
But it's minus.
Nope, it's still infinity.
What's
In the
infinity
magnitude of things.
It's
You know the little kid at the beach who takes the cup of water and pours it in the ocean? Do you think it's gonna raise the water level?
I mean, it will.
little bit.
Like, it will.
No,
No, it won't.
you just won't be able to. No.
Civil.
Does theoretically raise a lot. I have a question.
Even like.
What is
other-
infinity
there are enough
minus
kids
infinity?
going
Yeah.
to water.
Oh, infinity minus infinity is an indeterminate form. I have made it equal a half. I've made it equal 10.
So
I-
can it equal
9.
It can
1 to the
equal 0.
infinity, which is
Different
apparently
different
E.
types of infinity.
There's different sizes of infinity.
Wait, but where does that come from? Because I get the, indeterminate when you're dividing
That's
by
how it works,
infinities
not just
and you just cancel out the infinities. But
Is it
how do you subtract one infinity from another? Because then you have to quantify each infinity.
I can do that, Eric. It's chapter 8. We'll talk. Come by at lunch. I
Do not.
dare you.
Chapter 8.
So, Eric, come on by. See you at lunch. We'll chat about it then,
Okay.
mister.
Obtain the quantum knowledge.
Listen, y'all. Be careful what you ask. I might answer you. Okay.
God, my answer.
All right. So this thing. Josh, find the particle's displacement for the given time interval. What does that mean and how do I find it?
Displacement is the distance, but integral minus it. So
Can we say the
you
absolute?
add the negative to the positive.
You need a job in politics because you just said a lot of words with no substance. The thing where you do the stuff and there's integrals involved because this is calculus. Yo.
Subtract the negative.
As it continues. Yes. Politics. Vote Josh. Asher, help us out.
Just be
The
the
ballot in 30 years.
Sorry, other Asher, this one.
Just be the integral of
Okay,
but not absolute value because that would make it total distance.
okay. So the displacement is over 0 to 9, integrate the velocity, and it tells you how much distance has changed. You might have gone, because here, 0 to 5, we went forward, and then we turned around, and maybe this was 20, and this was 17, so our displacement would be 3. I ended up running forward, turn around, and run backwards, and I'm 3 feet from where I started, possibly. We'll do the integration here in a second. But that's displacement. So integrating, raise the power, divide by the new power, 0 to 9. So 90 minus 81 minus 0. So we have changed 9. What are the units on here? Do we have any units? I don't. Oh, meters. We are 9 meters in front of wherever we started. And they didn't tell me where I started, but I am 9 meters ahead.
If it was negative, it would be behind.
If it was -9, I would be 9 meters backwards from wherever I started.
So it's 1 meter per second.
Ooh, I wouldn't say it's 1 meter per second, that's the net change. Isaiah?
So you took away the per second into the interval, right?
Yeah, I took away the per seconds when I did the integral. Why is that? Because this was meters per second times seconds. The seconds cancel, and I end up with just meters.
So if you did the derivative, what would you put it as?
Derivative of the integral? Or
No, just the derivative of the velocity.
derivative of velocity, okay. Okay, different question. So velocity was 10 minus 2t. So that is, how is my meters per second changing dt per second? That's going to give me meters per second every second. If you're familiar with gravity, it's meters per second squared, feet per second squared. So this derivative is just -2. It's a constant in this problem.
You just add another per second.
Yes.
Isn't that the displacement just asking the position?
Oh, no. This is not asking where it's the position. You can't.
It would be the same answer.
No. Francis, where did we start? Pick a number. Not 0. If we started at 3 at time 0, where are you after 9 seconds? The position at 9 is where you started at time 0 plus your displacement. So where I ended up, Francis said, I'm feeling like we started at 3 at time 0 plus whatever I integrated. So you end up at 12. You started at 3, added 9 units to it. Hang on. So these kinds of questions are often question 1 on the AP exam. They give you some kind of like, oh, the rain is filling the tank and it's filling up at this rate. Oh, someone came by and started to take water out, or it springs a leak and it's leaking at this much, it's going in at that much, and they want to know after 5 minutes how much water's in the tank. You need to integrate what you lost, you need to integrate the rate of which it's being gained, and then you need to remember maybe there was some water in there in the start. Sorry, yeah.
If it doesn't ask for units, so
It is always a good idea to put units. If they say in their question, indicate units, they will be taking points off if you don't.
Is that on the answer or the calculations?
On the answer. In the end, if you said, okay, I got 9, and then you said 9 meters, that's my displacement, that's fine.
what if I said 9 seconds? What if I got it wrong?
If you got the units wrong, you're toast. Whether they asked for units or not, if you wrote the wrong units or made some up, which BC Calc does, I'm like, tacos per second, like what? They made units up,
Wait.
they will take points off.
For like a corn question, that's like a conceivable corn per second. Is that
Sometimes they give you weird units, and if you keep the weird units and they didn't ask for them, if they're weird units and correct, that's fine. But if you make things up or you get the units wrong, if you tell me feet when it was meters, if you tell me seconds when it was hours, you're wrong.
So I should probably not put them.
Don't make them up. Make sure you get them right.
If I were to find like the particle's distance over the integral, would I have to take the integral of
Okay.
0 to 5 and then 5 to 9?
Okay, hold on. So Francis, you are so smart. It says the initial position. I had it covered up. You picked 3. It means 3 here anyway. So what is the position's final? What's the particle's final position? Where did it start? Net change 9. End position is 12. So I think, and on it, here you go. This one. All right. How do I find the total distance traveled? Yeah.
You integrate 0 to 5, and then you integrate 5 to 9.
Why do we go 0 to 5 and then 5 to 9?
Because from 0 to 5 is positive, and 5 to 9 is negative.
So there's going to be a problem with this. I mean, yes, I need it. Noah?
We do the absolute value.
Okay, how do I do the absolute value? Like, okay.
Minus the 6. Fine.
Noah, that's right. You can do the absolute value. How do you do that by hand?
You just do it and then only do the
Cross your
confidence.
fingers.
Minus.
Then it's just 9.
Here's the graph of velocity, 10 minus 2t. It crosses at 5. So I'm finding that area and this area. So Noah, if you just, what do you mean? I don't know how you say do the absolute value. You, by doing absolute value, it says make that negative area, that y value pop up. Yeah?
So you're just adding absolute value of the 5 to the 9.
Ah, okay. So that was going to be my question. This stuff here, as written, when we found the velocity, this was negative, and that's going to give me a negative area. So I could subtract that negative number that I get out. I could put an absolute value bars around it and find whatever number I was, make it positive and add it. There are choices. Pick one that's valid.
Yeah.
Sure.
I don't. Why don't you just do absolute values?
How do you do, okay. Sure, do absolute value. You have no calculator. How are you going to do absolute value?
What with the 9?
How-
With like 9 to 0?
Yeah, how do you do this by hand without a calculator? You need to do what Keon says to do, which is split it up.
Oh, you
He knows that it breaks at 5. Stops being positive, the velocity stops being positive 5 and starts being negative. You have to pull it into 2 pieces. I'm doing the wrong thing, sorry. So this is 50 minus 25 minus 0 minus this side, 90 minus 81. Minus 50 minus 25. 25 minus 9 minus 14. Minus 25 is 16. So your Fitbit will say, even though your displacement was 9, you traveled 41 meters. Indy?
Could you just do plus and then absolute value bars outside of like the integral? So like
Okay.
whatever you get, you do the absolute value of that.
So instead of writing this, you could have just said what I think you just said, which was absolute value 5 to 9. You could do that. Some people like to trade these and say 9 to 5 because that then makes it positive. There are a lot of valid choices.
Why is it when we did those other FRQs that it's just the integral like absolute value?
Okay, if you get a calculator, the calculator knows make this negative y value pop up, and you can type it in on the calculator, and it knows to turn it around. But if you're doing it by hand, you can't. Oh, one other thing. Sometimes they'll say set up but do not evaluate. And Noah, if it says set up but do not evaluate, you are good to go and stop right there and be like, absolute value, do it yourself, chumps. Okay?
So like, if you don't have that first part to like set you up, and, like you figure out that you need to
that it breaks
split
at 5.
So you still need to do that step even if.
So if they didn't give you these beginning things that are leading you through and just said find the total distance, you need to know to find, if it's without calculator, where does it break and start to become negative? Sydney?
Can you explain how you went from positive or plus or minus to just minus? Like from the
Oh, this was plus a negative.
Oh, I see.
So adding a negative is the same as subtraction. We're good? What happened to the 3? Is this distance traveled?
No.
I'm saying you started at 3. Did you travel in that 9 seconds to get the 3, or did you start there? You started there. You were cheating, or we gave you a handicap. We let you start 3 feet ahead of everybody else. Then we started the clock. Then your velocity gets added up. So the 3 is not part of distance traveled. It is just where you are at the very beginning. What you traveled was all of this business that we got out of the interval.
But don't be asked for final position. Does that matter?
Final position, okay.
I don't know.
Okay, final position is, where are you at 9, is where did you start plus your displacement, which is just the integral, no absolute value. So this was 3 plus 9. My position at the end was 12 meters from the origin. My total distance traveled was the absolute value of velocity, and I traveled 41 meters. You do 8 times around the track, your displacement is 0, but your Fitbit will tell you you went 2 miles. Oh my goodness. See what I mean by, is this familiar?
Yes, sort of.
Like, was it at the beginning of class, or is it now finally like, oh yeah? Because we just spent more than half the class on this one thing. Yeah, you know, not a big fan of this question, but so, all right. Potato consumption in a particular country. I heard someone say Ireland. They like potatoes there. This is a T. How are we going to find how many bushels of potatoes were consumed? Asher in the back, what do we do?
You take the integral from 2 to 5 of 2.2 plus 1.1.
So, do you guys get that? Let's see. This is potatoes consumed per year. Potatoes per year times years. What's the end unit of measure? Potatoes. Everyone's favorite. Yeah.
So, would they be able to do March of a certain year, and you have to put fractions of the year?
I have seen the AP exam be ridiculous, and they're like, on June 13th, what's the number of blah, blah, blah? And you need to remember then, well, it wasn't a leap year, so there were 28 days in February. I've seen this once, and I was like, that is rude.
What?
It was long enough ago that I don't think they'll do that again. But yeah, they made them find what day of the year that was.
At least
Is it the leading up question?
I hate leading
No.
They just wanted you
You
to
have
know
to
what
do
they
2 to 5.
Okay, well, let's check. It says so T in years 1970 is 0.
Okay.
So 2 to 5, okay? And then you would have to just type that in. Carson, making any sense? So integration is just how much stuff got accumulated. And in this case, it's the number of potatoes that were consumed. The rates can be anything. We are most familiar with velocity and acceleration, but it could be water going through the tunnels or through tubes or something. Okay. Yeah, I wanna try this. Can you guys do A and B of this free response question? Write it down, give it a try. And this says a calculator is permitted on this piece.
Is
Yes.
that e to the negative t or 1?
E to the negative t sine t. And if you're fancy, you can do quite a bit of this without a calculator. No. Okay. Up to you. Sam is feeling fancy. He's not even reaching for the calculator. Neither is Eric. No. You're all over it.
You have like classes you can put on suddenly like all the students are like doing what you want them to do. Like you take them off and suddenly it's all
Sam,
like,
in my mind, you're all doing everything perfect. It would make my life so much easier if that was only true.
I did well. I did pretty well on the test.
That's that. I got a weird looking graph.
This is 15 cities, 0, so it's 0.
Well, Sam, what do we need to do to find when the particle is at rest?
So we need to find when v of t is equal to 0.
Okay. Is it factored? Is velocity one term times another?
It is here.
It is here. So yes, it is factored. So where this is going to be 0 is where either this guy is 0 or that guy is 0. Okay. Forever in Algebra 1 and stuff, we were like, oh, factor it, turn it into one thing times another. Where are the zeros? Either when this guy is 0 or when that guy is 0. So in the unrelated problem, we'd be like, oh, either x is 2 or x is -7 for this to be 0. This is one thing times another, so either e to the negative t has to be 0 or sine has to be 0. E to the negative t looks like this. When is e to the negative t 0? Never. Thank you, Will. Okay, now when is sine, Safal, when is sine 0?
1.
1 pi. Which happens to be the ends and exactly in the middle. So when is the particle at rest? Those places. Okay, over what intervals is the particle moving left? What do we need to do to check that, Lana?
We need to plug in and see where it's negative positive.
Where, what is it?
Where v of t.
Where velocity is 0. And remember that velocity, like this number line isn't enough justification, but it helps you organize your thoughts. So putting those zeros on the number line, 0 to pi.
Can you just find like 1? Can we just plug in 1 or does it have to be a pi value?
You can plug in the number 1. Do you know where the number 1 fits in this number line?
Well, it's in between 0 and pi.
Okay, yeah, it's in between 0 and pi.
Yeah.
But, okay, this guy is never going to be negative. Sine is positive in what quadrants? 1 and 2. Isn't that here? Yeah. Woo. Sine in quadrants 3 and 4. So where is it live? Where is the particle moving left?
The particle's moving left from pi to 2 pi, not including 2 pi.
Because
That is that is when the velocity is negative.
A complete answer, yes.
So for number C,
Number C,
I
yeah,
mean,
I got you.
for C, the minimum velocity of the particle, is
Okay.
that just zero?
Hold on.
Because otherwise it's
No,
just
because the
limits,
velocity
right?
goes negative. Is negative less than zero? You are not breaking even, you are in debt. You can go
Well,
lower
okay,
than zero.
Velocity, okay, that's not speed. Okay.
Okay. Okay, we'll skip this for a second. What is the minimum velocity, Isaiah?
I have a question.
Yep.
Is there a way to make our calculators spit out like pi and stuff?
Mine does. You guys aren't allowed to use mine. First of all, y'all can't figure it out. You ask it things like 1/7 and it tells you that equals 1/7. You get really frustrated and you throw the calculator back to me. The TI-84 and 83, no, I don't think you can do that. But here, where is the minimum blah, blah, blah? What do we have to do to find maximums and minimums? The derivative. So if I want to find the maximum min of velocity, do I need the derivative of velocity? Yes.
Acceleration.
Which is the question of part B. So if velocity is this, the derivative of velocity is acceleration. Morgan, how do I do the derivative of this product?
E to the negative t minus, oh wait, no, it's, yeah, derivative and that,
First times the derivative of the second, so e to the negative t times
just
derivative of sine is
cosine.
cosine t plus second times the derivative of the first. What is the derivative of the first?
E to the negative t minus 1.
Not minus 1.
Or
E to the stuff
minus-
times derivative of stuff. Keep the parentheses so that doesn't look like a subtraction. It's a negative and it's being multiplied. So right there, you don't have to clean it up. It'd probably be better if you did, but right there, that's our equation for acceleration. So, Amalia, using this equation, how am I going to find where the velocity hits a minimum?
You would set it equal to 0.
So we found the derivative of velocity, which is that acceleration. Set that acceleration to 0. Now I need a calculator because I don't know when this happens. Well, maybe I do.
Isn't it just where cosine and sine would be 0?
No.
Acceleration goes from cosine.
It's where cosine and sine equal each other.
Wait, how would you do that?
Is this not all the fours?
Not all the fours.
Not all.
Pi over 4 and 3 pi over 4. Where does sine equal cosine at pi over 4 and 3, or
Not all the fours,
7,
you're right.
5 pi over 4. First quadrant and third quadrant. They're either both positive root 2 over 2 or both negative root 2 over 2. And then we need to, sorry?
How did you do that last part?
Uh,
How would you plug it in the calculator?
type the equation for acceleration in on your calculator, set the window 0 to 2 pi, and find out where it crosses the axis. I did it with pre-cal. So where does that first thing equal 0? E to the t is never 0. Where does this thing equal 0? It's when cosine equals sine. And I am going to do a thing that we tell you to never do. Dividing by the trig function cosine. Sine over cosine is known as tangent. Whereas tangent 1 at quadrant 1 and quadrant 3. Noah?
How did you get from the thing part B to e to the negative t equals cosine t and sine t?
Factor out e to the negative t. I am left with cosine on this part. That negative is still there. Good. Okay, then on my acceleration number line, what am I testing in here? Like, let's see. Where do we have the minimum velocity? Why?
Because it's going from negative to positive,
What is it?
like on the slope.
Okay,
Not, is it asking for like the very smallest?
yeah, it's asking for the least. So here acceleration is going up, and then it's going down, and then it's going up again. So the change in the velocity was increasing till here, then it was dropping, and then it hit its all-time, the velocity hit its all-time low.
Wait, why
Here.
is 0?
Why is,
What is this about?
oh, we should also check the endpoints. Oh, come on.
No, I just
Wait,
realized
because
that
0
what is
is not a
where.
0, right?
Zero's not a zero. What do you mean?
I mean, e to the 0 is just 1.
E to the zero is one.
So it's not a 0. Is like, right?
Let's see, hang on. So I would check these, our minimum is most likely here, but check your endpoints. Do I plug into acceleration or do I plug into velocity? Velocity, because that's what I want to know. And you said e to the 0 is 1. What's e to the negative 0? Still 1. Sine of 0? 0. Okay, putting in the 2 pi, e to the negative 2 pi, whatever, times 0, still 0. 5 pi over 4, sine of 5 pi over 4, negative root 2 over 2 times this number. Whatever it is, it's something kind of big.
Why are we
And
plugging in for the velocity? Wait,
Okay.
am I just confused?
why do we use acceleration to find maxes and mins of velocity? When is the rate of the velocity changing? That's acceleration, but I want to know what is the biggest value for the velocity. So this derivative told me where the critical points were, but I'm not going to test the velocity on it.
Oh, okay. We
Okay,
were
so,
testing points
guys,
determining the time,
Please
so
do
okay.
the delta math. It is challenging.
Oh, how exciting.
Yeah.
Doing anything on Wednesday?
Are we doing anything on Wednesday?